that we are having that source language and target language will be there. So that we have already discussed with their probabilistic language models we have been discussed. And I have shared that one research paper with you regarding that this one n gram and the big these grams will be there, the comparison and this will be there. So today we will just go ahead with wait. So we will start up with that word to vector model architecture is there. So in that word okay, now in word to vector model architecture, what happened? That basically what we are doing there in the previous one, that word to vector representation, what we are doing, we are having that a framework is there where whatever the that word will be there, and against that particular word, what we are doing, we are making a vector, and this vector is very useful when we are going for implement the things in Python language. This will be there. So what the that this what you are, that is see, continuous bag of word model will be there, as we have in the previous that session. We are having that in unit 1 we have discussed that the bag of word model will be there. So in that, this model is little bit means advanced with the bag of word model. What we will be there here, basically we are having that inputs will be there, and we are having the projection will be there, where we will do that the manipulations will be going on there, and after that we are having the output will be came. So the input will be in the terms of that we will be just because we are using the vectors will be there, so we are using that is that we are having that t minus 1 and t minus 2 will be there, and we are having the positive vectors will be there, plus 1 and plus 2 vectors will be there, and whatever the input that will be came from in the form of these vectors w, that will be goes to your sum means that the process will be going on there, the projection will be going on there, the manipulation will be going on there, and after that this manipulation we are getting that output for the same. Now skip gram model, what we are doing in skip gram model, we are getting that input from that this one that will be in the form of that vectors will be there, but here in skip gram model what we are predicting the target context using a word. So what happened that whatever the input that we have been providing there, the projection will be going on, and after the projection will be going on, we are getting that w t minus 2, t minus 1, t plus 1, and t plus 2. So if you have been seeing that in that continuous bag of word model, in continuous bag of model, it is the vice versa, that in n-gram is the vice versa, that is the skip gram is the vice versa for the same. Now word to vector models will be there. Now we will discuss that what will be going on there in word to vector models. The above two models are used to generate the vectors for the words in the text using word to vector approach to form the word embedding. Okay. Now that will be the same that we are using in that our continuous bag of word model. Now that what will be the steps that we will go ahead for that this one continuous bag of word model will be there. The embedding layer with the initial random weights will receive the context words as an input. This will be there now. You have been seen that this will be the input w t minus 2 t minus 1 with the individual weight they are getting. The lambda layer will receive the word embedding as input and perform the average for the word embeddings, whatever the lambda layer will be there. And then the dense softmax layer receive those words embedding for the target word prediction will be going on there. And the generated target word and expected target words are compared to find the loss value, whatever that we have been used there, this one lambda layer and embedding the software layer on the basis of this, whatever that we are expecting target will be there, we will just use that thing. And the generated targets words and expected target words are compared to find the specific loss values that we are using in it. Then after that, the back propagation process is done with each this embedded layer that same that was seen, that your artificial neural network is there now. So whatever the input we are going to, that for the process of the neuron will be going on, we are assigning a weight. That process will be known as that your back propagation process will be there. So same thing that we are doing there. Now, this will be the important thing will be there from where we have been started. We have started that now we are using in above model that we have been discussed, whatever the input will be there, that we are having t minus 1, t minus w, t minus 1, t minus 2 will be there. Now that whatever and the other inputs will be t plus 1 and t plus 2 will be there. Now we are representing that with the help of this architecture will be there. Here what we are assuming, that we are assuming that whatever the t minus 1 will be there, it will be goes up to that t minus n, and whatever that our t plus 1 will be there, that will be goes to t plus n will be going on there. So whatever the inputs that we are getting from these means t minus 1 to t minus n or t plus 1 to t plus n. So these all these inputs will be first goes to the embedded layer, embedding layer. In embedding layer, whatever the vocab size will be there, that we are using that this thing, and we are creating that vocab for the same. After that, whatever these vocab size x embedded and dm we have been created, that goes to the next phase. They are having the individual will be there, just like that is that we are using that I minus n and sorry t minus n embedding, and t minus 1 up t minus 1 to t minus n, and here we are having t plus 1 to t plus n will be going on there. And whatever these the embedded layer function will be clear, that is basically used for the vocab size that we are using, and it will be bifurcated according to the different ones that we have been bifurcated. And what is the lambda layer using? Lambda layer is now providing that average embedding, whatever the inputs that will be received from t minus n, and from that t minus 1 to t minus n and t plus 1 to t minus t plus n. After that, the lambda will be there. Then we are using an average embedding will be there. W avg will be there. Here that we are getting that average embedding, we are getting it from this one. And after that, the dense layer will become, and dense layer, what will be the dense layer will be there? Dense layer will be provided by that softmax will be there. And whatever the values that will be came from there, from the WT, then now we are just compute the loss and the back propagation for the same. So same thing, that whatever we have been discussed there in that this architecture, same thing will be there. You will see that again the steps will be there. The steps will be there. Now, the embedding layer with initial random weight will be received in context as the input, that is our W minus 1 to W minus N. And same thing is we are having, that is T plus 1 to T plus N will be there. After that, lambda layer will become, then softmax layer, this softmax layer will become, and after that, whatever the generated target and the loss value we are getting from with the help of that back propagation process is done. So that we are using, that was this one for that our continuous bag of word model. Now next one we are discussing, that is that skip gram model. In this model, the target word is given as input and the context word are to be predicated. So whatever that continuous bag of word model will be there, it is the vice versa or the reverse of this model will be there. We have already seen that is in that pictures, the pictorial representation. In that pictorial representation, if you have been seen, this is that the model of the skip will be there, and this is that model that we are using for that cow will be there. Only that whatever the continuous bag of word model will be there, the vice versa will be there. A skipgram model will be there. So in skipgram, now we are discussing that skipgram. In this skipgram model, multiple words to be predicted from a single word or a center word. That is that the advantage of this model will be there. The corpus used for skipgram is represented as target, context, and PIS and INIS. What is that PIS here? PIS will be the positive input samples that we are using, may be represented with the values that we will represent it with the 1, and they are used to represent context words relevant pair with respect to the center word. What will be the input, the single word that we are using in it, and with the help of the single word, what will be the different outputs that will be getting out there. NIS will be that here, that will be the negative input samples will be there. And in negative input samples, we will represent that will be in that minus, means that will be the negative values will be used. And whatever these representations will be there, that representation will be going on in go ahead. Now that we are just going to go through an example. So we are having that one example is there in skipgram model. NLP is playing a vital role in chatbot creation. So we are having that one sentence will be there, that is NLP is playing a vital role in chatbot creation. Then consider the window size as 2. We are consider it here. The word will be paired as below. That is positive input and sample corpus representation will be there. So we are pairing it just like the first one. What will be that NLP? So we have just this pair it NLP, and playing will be that in 1. And is that we have been discussed that thing in that our the previous one lecture, na, she is that, so she is, and that same that this one, our same method will be deploying it there. So whatever this one NLP is playing will be playing a vital role in chatbot creation will be there. So that will be there. Only what we have been putting down, we are just putting down the positive inputs will be there, and that will be represented as 1 there. This one. Same thing we will be doing there now. I will just go through it. The previous one. This one, the probabilities that we are using for the this 3 1, probability of A, B, C, D will be there. So same thing we are deploying there, but instead of that this one deploying, that we are using that one, that we are having the positive inputs will be there. So we are using that one will be there, and we are comparing it with this t minus 1 to t minus n, and t plus 1 to t plus n. Same thing that we are using for the values will be there. Na? This is 1 for the positive input values and 0 for the negative input values. So same in that this sentence we are having that the positive values will be there. So that's why we are using 1. So now that we have used that is for the positive value creation will be there. No? We are using that positive input samples. Now we are discussing that second one is the negative input samples, that how these negative input samples will be working there. So instead of that, all things will be same. So instead of one represent that positive sample, now 0 represents our that will be that the negative sample will be there. The same example that we are using there. The example will be that NLP is playing a vital role in chatbot creation. So same thing we are using there. So here, if vital word is given as an input center word, then the model will try to give the context words and role will be there. Now, how these things will be going on there? Uh, the target and context word pairs will be transferred as input to the embedding layer. Then after that embedding layer generates the dense word embedding for the each of the 2 words, whatever that will be getting from there, from the input from that is our t minus 1 to w, t minus 1 to w, t minus n and w t plus 1 to w t minus t plus n we are getting from there. After that we are just getting these things, and the merge layer is used to calculate and generate the dot product of two embeddeds what we are using, that is the t plus 1 and t minus 1 that we are using it. After that whatever the dense and sigmoid layer, that what will be the using, that will be there, whatever the input that will be generating. So we are generating that two things will be there, that is 0 and 1. One is for the positive input samples and 0 will be for the input samples. Then whatever the generated outputs that will be compared by that positive input samples and negative input samples labels, and the loss value of the specific will be calculated there. This is the important thing. Whatever the positive input will be we have been calculated in the above layer, the this one is our merge layer or embedding layer. After that the loss will be calculated there, and after this loss calculation, what will be the back propagation for each epoch is done, and update the embedding layer to reduce the loss. And this process will be continuous up to that our t minus n and t plus n this inputs. So how the things will be going on there? We are using that first. We will be go through that WT. What will be the target word will be there. Embedding layer will be there. We have already discussed the embedded layer will be there, and we are embedding will be there. And the other hand, what we are using the context word will be there. Same thing we will be doing with that embedding layer will be vocab size, and this will be there. And whatever the WT and WC we are getting from there, we are just providing that the dot product of both will be there. After that the dense layer will be the accountable to get that whatever the positive inputs that is positive input samples will be there, and the negative input samples will be there, and whatever the comparison that will be going on in the dense layer that is sigmoid will be there. So we will get out this one or zero will be there. According on the basis of this, with the help of back propagation, we are using this concept. And in it whatever this dense layer and this Cowboy model and this engram model will be there, their pictorial representation as well as the architecture and the example you should be prepared with yourself also. You will be, instead of taking that this one high example of this one positive that NLP is playing a vital role in chatbot creation, you can take it that this one any other small example, that he is a cat and something will be there. So that cat is playing, cat is that some sentence, Ram is boy, and something that you have been taken according to basis of that sentence, the small sentence you can use it. So same thing that we have been discussed in there. So same things that will be in that this model architecture. If we will go through that the previous one research paper that I have shared with that CBOW and continuous bag of word model and skip gram. Now you are having the clarity that what will be going on there in that this both the mechanisms in model architectures, how they will performing the computations. Okay, student, that's all for today.